Hello there, Math 133 students. It's been requested that I go over how to do this My Stat Lab problem, which is from section 3.1. Now, where this shows up in your particular homework set is kind of variable from semester to semester, but this is number 37 from the textbook. So if you open up the textbook, or if you can see in the top left corner, it says number 37, this will help you with that. So Benjamin owns a small business. Besides himself, he employs 9 other people. The salaries earned by the employees are given below in thousands of dollars. Benjamin's salary is the largest, of course. So we're going to complete parts A through D. Now, I'm not going to do this particular problem. I'm going to do the example, which works the same way. So these are our numbers, 15, 30, and so on. And my first job is to determine the mean, median, and modes for the salaries. All right, this is one problem where it's going to kind of help us to write it in Excel or Google Spreadsheet, which is basically like a light version of Excel, and it's free, so that's awesome. And use the calculator to kind of help ourselves. You actually don't even need the calculator per se. You could actually do it all with Google Spreadsheet or with Excel, same thing. All right, so let me start by going to Google Spreadsheet and typing in these numbers. So one second. Okay, so I just opened up a little Google spreadsheet right here and I just started typing in some stuff. Google Spreadsheet is the Google version of Excel. It's really nice and handy for a lot of our stuff, for a lot of simple problems. And of course, if you wanted to, you could work in Excel. Excel works almost identically for a simple problem like this. So I just put the original data set right here. I want to find the mean, the median, and the mode. Now, in Excel, the way you do this is you type equals, and unfortunately for us, they use the exact wrong word. They use average. Average is a terrible word because average is actually mean, median, or mode. They're all averages. So this is the only context where, for your purposes, mean and average are the same. For every other purpose, all 3 of these are averages. But that's the Excel formula, so there we use it. So you type equals average, and you want to start that data set at B2, cell B2. You want to end it at B11. So by doing that, you can see that it highlights where that data set is, right? B2 to B11. All right, so that's that. Median, you type equals, then you have to type the equals first, median, parentheses, and then do the same thing. Say B2 to B11. I'm doing that by using my mouse to highlight it, but you could also just type B2, cell B2, which is the 15 right here, colon, cell B11. Now for mode, you're kind of on your own. You just have to look and see which is the most frequent, which is 55. So 55 is the most frequent. Now in my calculator, the way I do this is stat, edit, type the data in, which as you can see, I already did in L1. There it is, 15, 30, 40, and so on. So then I go to stat, calculate, number 1, and then I tell it L1. I want you to run one variable stats on that first list. Go down to calculate and press enter. And there it is, 49.5, just like Excel said it was, or Google Spreadsheet. And I can scroll down with my down arrow. There's the median of 52.5. The calculator does not find the mode either, so you're stuck with finding the mode on your own. It helps if the data set is organized and sorted from lowest to highest, as it is in this case. All right, so I would type up those answers or enter those answers in. Keep in mind that our data set is thousands of dollars. That's our unit. So we would have to use that. So the mean is $49.5 thousand. The median is $52.5 thousand. And the mode is $55,000. All right, so business has been good. So as a result, there's $25,000 in bonus pay to distribute for Benjamin. So we're going to examine a few different options. So this first option is Benjamin is going to take that $25,000, divide it amongst 10 employees, and every single person gets $2,500. But $2,500 is $2,500. So what we're going to do is we're going to add $2,500 to each person's value. Now, this is the time where Excel and or Google Spreadsheet is a lot easier to work with than your calculator. Because what you want to do is you want to tell it, hey, take that value of this employee, which was 15. So I'm going to click on that and say cell B2. Take that person's score, and I want to add 2.5, enter. And Excel or Google Spreadsheet will automatically calculate it for you. But it gets better. If I click back up on this cell, and then I move my cursor to the bottom right corner, see how the cursor turns from an arrow to a plus sign? The plus sign is what you want. It's called the handle in Excel. So you click and hold down with your left mouse button and you drag down the column and then you lift up and it will find all the data values for you. So this one is 32.5, 42.5, 52.5, and so on. And now you want to find the mean, the median, and the mode of those values. So you can type equals average of these data right here, and you get 52. Or since you already had the formula equals average for the B's right here, B2 to B11, what you could do is click on that cell, get your cursor into the bottom right corner there and drag it to the right, and it will automatically find it. I can do it with the median as well. Drag it to the right, or the mode, or you can actually do all three of them. Highlight all three, mean, median, and mode, drag to the right, but the problem is that the mode won't be correct because there is no formula for mode. Actually, there is, but it often doesn't work. So this one actually would work. So you could try equals mode on this one. Just keep in mind that mode as a function is often not consistent. If it's a bimodal distribution, which this is not, but if it's bimodal, Excel will not find it correctly. If there are two modes, it won't know what to do. So for example, just let me quick, if I change this to 52.5, see there it is. This is a mode and this is a mode, but Excel will only find the first one. So mode as a function on Excel is not consistent for anything other than a unimodal distribution, a distribution where there is a single mode. And there has to be a mode for it to work. So the mode function itself, you're better off just kind of eyeballing it and saying, yep, that one's 55, that one's 57.5. All right, so there we go. We've got these three. Now to get them with your calculator, you go to Stat, Edit, and you'd honestly just have to type in the data, 17.5, 32.5. I put it in an L2 because I thought maybe we'll want L1 for some reason, so I put it all in L2. Then I go to Stat, Calculate, number 1, but you have to tell it, if you pick L2, you have to tell it L2. So L2, go down to Calculate and press Enter. And there you have it, 52 and 55. So with Excel or with the calculator, your choice, right? Do either one, but you'll get the right answer. All right, now for option C. Oops, and by the way, there you go. So the mean, the median, the mode, all that good stuff. All right, so now what do we do for the second option? Each employee gets a 5% bonus of his or her original salary. Add the bonuses under this second plan to the original data set, create a new data set, and recalculate the mean. How do they compare? All right, so the difficult part about this one is figuring out what your new data set is. It's the 5% bonus. So let me go to Excel. This will be a lot easier in Excel than it would be anywhere else. So we can kind of ignore this part. This was option number 1. But option number 2, I want a 5%. So here's the thing. You want this person with 15 to be multiplied by 0.05 because that's 5%. But if you just do that, then they're having $0.75 thousand, which is like 750 bucks. Because remember, all this is in $1,000. Well, that's not really good. You want them to have their original data set, right? So you want to say, look, I want 15 plus they get a 5% bonus. So if I say B2, that's the 15, plus an extra 5% times B2, that's another, and that gets you 15.75. Now the mathier way to do this, if you'll notice there's B2 in both of these, so the mathier way to do this is B2 times 1.05. That's kind of the more algebra way to do it. Notice I get the same number. The 1 gets you the full 100%, they get their full $15,000 salary. The 0.05 gets you the 5% bonus, right? Now, either way you want to do it. If you want to do B2 plus B2 times 0.05, great. If you want to do B2 times 1.05, fine. But either way, you want to figure that out. And then you want to, it's so much easier to go up to that cell, go to the bottom right corner so that your cursor turns into a plus sign, hold down on the left mouse button and drag it down and lift up. And then automatically you figured them out. Otherwise, you have to sit there and do it yourself, which is really annoying. And you can do it with the calculator as well. So let me go to Stat Edit. I'll go over to L3 here. And what you want to do is tell it 15 plus 0.05 times 15. Enter. 30 plus 0.05 times 30. You can see how this gets tedious. 40 times 1.05. It's easier if you multiply by 1.05, and so on, right? So I know what this one's going to be. It's the same. Then 55 times 1.05, 57.7, oops, 75. So either way you want to find it. I knew these last two are the same because it's the same number. 60 times 1.05, 85 times 1.05. It's just easier if you multiply by 1.05. But notice you get the same answers, both of them. All right, then you just have to run one variable stats in the calculator if you're going to use the calculator. So, but I would want it L3 because that's my list right now. And then go down to calculate and press enter. So I can see 51.975 and 55.125. In Excel, it's even easier. I just highlight these three cells, actually these two cells, because we're doing mode by hand, and I just drag them over. Drag them to the right. So I move my cursor, so I highlight the mean and median, and I move my cursor to the bottom right corner and just drag it to the right, and it'll automatically calculate them. And this one I just know is 57.75. It's just easier to do it by hand. Just in case it's bimodal, it won't find it anyway. All right, so there we go. So let me type up those answers. It's interesting to note that the 5% rate leaves the mean roughly the same. I mean, 52,000 and 51.975 thousand are very similar. Who it hurts the most rather than the flat rate is the poorest of the employees. So the flat rate gives the lowest level employees a good $2.5 thousand bonus, whereas a percentage is very small for those employees and much larger for the higher income people. So the persons that the percentage benefits the most because its percentage would be the high income people. The person that it helps the least would be the low income people. By the same token, a flat rate's probably better for the low income people and not so good percentage wise for the high income people. So as a third option, Benjamin decides not to give his employees a bonus at all. He keeps it all for himself. So use this plan to create a new data set. Well, that's going to be very similar to the old data set, but that last number, so all the numbers are going to be the same except for the last one. So instead of 85, it'll be 110. So let me show you how I came up with that. So let me go back to the spreadsheet real quick. So if it all goes to Ben, then every single one of these is exactly the same, right? So I can just drag these down. The only one that's different is this one right here. So equals 85 plus 25, and it's 110. So now I want to find the mean and the median for that data set. So I'm just going to drag these down. And notice the mean and the median, very interesting. The median is 52.5, which is what it was for the original. The mean, however, is now 52, which is what it was if you gave a $2.5 thousand bonus to everybody. The mode is still 55. That has not changed. Now let's look at this with the calculator real quickly just to double check myself. And then we want to go in and kind of make a comparison check at the end of all of this because every single step of the way it's asked us how this compares to the originals. So let me just go in. It's easier for me just to use L1 because everything was the same. And all I did was I moved down to the 85 and typed over it with 110. Then stat, calculate one variable, second L1, calculate. And there it is, 52 and 52.5, just like we thought. So now let's make some comparisons because it wants us to kind of compare these values right here, which were the original data values, to what happens when you modify them. So adding $2.5 thousand, this is a higher mean, median, and mode, right, to the originals, right? All three of those numbers are larger, higher mean, median, and mode. This one, the 5%, is a higher mean, but not as high as the 2.5 thousand. Higher median, but higher than the 2.5 thousand, and then a higher mode, right? So this is also a higher mean, median, and mode, right? You can see that the mean is lower than option number 1, and the median is higher. Median and the mode are higher than option, or I should say option B, because this is for C, right? So option B. So option C has a little bit higher mean and median, but a little bit lower mean. Median and mode, but a little bit lower mean. All right, now what about C, right? Giving it all to Ben. Well, if you do that, then look at these two values. They're exactly the same, right? So then your median and your mode are exactly the same as they were. So median and mode are exactly the same as with no bonus. But your mean, because Ben is giving himself all that money, look at the mean. It goes to the highest level it can. It'd be the same as it, giving himself that money is the same as far as the mean is concerned as giving everybody money. One other thing to notice real quick is that these three values right here, they're actually the same as if you had taken 5% off of the original values. Let me just prove that to you. So if you type equals this times 1.05, you get 51.975. See it right there? So those three values for the 5% are the same as if you had taken 5% of this number. 5% of 52.5 gets you this, and 5% of 55 gets you 57.75. So these are each a 5% increase, right? Which is why it's variable for the mean versus the median, right? Because 5% kind of varies with the size. All right, that should be enough to help you with that, my math lab, my stat lab problem. I'll see you back here for more tutorials.